Hello and welcome back to the Enrichment series. In this episode, we're going to focus on exponential and log functions. And we'll get to log in the next part. So just focusing on this left branch over here. This is giving you the general form of an exponential function. So we have a number raised to a variable is what that's telling you. An example of that would be maybe 5 to the x. And that's not to be confused with a power function. For a power function, you might have something like x to the 5th. So it's reversed in that situation, but for exponential, it's a number raised to a variable. All right, and let's go over some key features for kind of the basic version, which is y equals 2 to the power of x. And so these are the features that you want to know for the pre-cal class. So number 1 over there is showing you intercepts, and an exponential function is always going to pass through the point 0, 1, unless there's some sort of transformation that changes it. And that's because if you plug in 0 for x, you get 2 to the 0, and any number to the power of 0 is just going to give you 1. And then over here for number 2, domain. So we can plug in any number for x. So that's just going to be -infinity to infinity. And the next one would be range. This is a little different because, we can raise something to a negative number, but that's just going to change it into a fraction, and it's just going to get smaller and smaller and smaller, and basically approach 0. But you can't really make it negative unless, again, you do some sort of transformation. So the range of this is going to go from 0 to infinity. All right, positive and negative, that just means, is it above the x-axis? Is it below the x-axis? And just for the basic one here, it's always going to be positive. So I can circle positive, and that will always happen from -infinity to infinity. Number 5, increasing, decreasing. That just means the sign of the slope. So increasing is if you have a positive slope, and decreasing, negative slope. So looking at this graph over here, one thing that I like to do, even if I don't draw it directly on, is to do little tangent lines. Because usually when we think of slope, we think of a line, and it's kind of hard to see on a curve, so it's better if you draw lines. But anyways, we can see that all of these lines are positive, and so we can say that this function is always increasing. It's exponential growth, we would say. Number 6, concavity. This is from a couple videos back, but 2 different ways you can look at this. The easy way is kind of this rhyme where concave up is like a cup, concave down is like a frown. So in this case, our graph is forming a little cup, so we would say concave up for the entire time. Yes, sometimes I just write cup, which is perfectly fine. Another way you can look at it is concave up is when the slopes are increasing or they're becoming more and more positive. And you can see that on the left here, the slopes are pretty flat, but then they get more and more steep in the positive direction. So then that also tells us it's concave up. And then it would be the exact opposite for down. It would just be more and more negative. And then you get something like this, like a rainbow. Okay, end behavior, that's just what's happening to the graph as you get increasingly negative and increasingly positive. You could write as x approaches infinity. We could say that y approaches infinity as well. And as x approaches negative infinity, y approaches 0. And I think I'll just write it that way from now on, but anyways. We have one more point, and that's going to be the asymptote. Exponential functions have a horizontal asymptote, and that's something you definitely want to remember. Okay. So they have a horizontal asymptote, and that's just going to be at y equals 0. All right, cool. So that is the basic one. Come back to the next part for some transformations.